Good morning, everyone. Today we're going to start with limiting agents. Now, up to now, we've done grade 10 revision. We've done basic mole calculations, we've done basic stoichiometry, and this is now the first grade 11 topic that we're going to look at. Now, a limiting agent is something that limits the reaction. It's something that's used up, and the moment that it's used up, the reaction is going to stop, and that means you will not be making any more product. So it limits the amount of product that can be produced. So for limiting agent, something is going to be in excess. There's more than enough. Not all of that is going to react, and we're going to ignore that one. We want to work with the reactant that is going to limit, that's going to determine how much product is going to be produced. Now, in the previous videos, the questions that we answered were questions where they were telling us that something is in excess, right? So here, for instance, they asked us, calculate the mass of sodium oxide that can be produced when that much oxygen gas reacts with an excess of sodium. So there they already told you you had an excess of sodium, and that told you you can ignore the sodium, right? We needed the sodium to balance that equation. But afterwards, when we knew sodium was in excess, we did not need to worry about sodium at all. We only worked with that oxygen that was the limiting agent there, that was going to react completely. So now in this next work, they're going to give you both the sodium and the oxygen. And now you have to determine first which one is the limiting agent. So let's look at the first question here where they ask us to determine the limiting agent. Now you have the mass, we're going to make that into moles, we're going to convert the volume into moles, and then we're going to have a decision step. We have to determine which one is the limiting agent. So let's start first by converting both to moles. This is the basic conversion that we did in that very first video. You work out how many moles of sodium are available and how many moles of oxygen are available. And now we have to work out which one is going to be my limiting agent. So to do this, we're going to ignore one of them. Let's say we're going to ignore oxygen. We're going to decide to see if all the sodium reacts, how much oxygen will that require? So we're going to work with our ratios. And we say for all the sodium to oxygen, always in the ratio 4:1, according to that equation over there. And then you work out how much oxygen is required for all that sodium to react. And when you get that answer, we're going to compare that is required with what we have available. And here you'll see we have more available than the amount of oxygen that is required. And that immediately tells me oxygen is therefore in excess. I have more than enough. And if oxygen is in excess, then that will tell you sodium is the limiting agent. And in all future calculations, I am going to ignore that oxygen because that is in excess. Right, let's move on to number B. In number B, they ask us to calculate the mass of sodium oxide that can be formed. So we need to determine that mass, and that means we need to work out the moles first. And now you just have to remember, we're definitely not working with the oxygen because that one is in excess. We're going to work with the sodium. Right, so we start with the sodium and we work from sodium to sodium oxide. According to the equation, 4 moles of sodium will give you 2 moles of sodium oxide. And that tells you that we have 10,5 moles of sodium oxide that is produced, and then just a quick conversion to mass. Right, moving on to number C. In number C, they ask us to calculate the mass that remain of that one that is in excess, and that was the oxygen. In part A, we worked out how much oxygen was available, 5,8, and we also worked out that for all the sodium, 5,25 moles of oxygen will be required. So that's how many is going to react. So if you take what you've got and you subtract what is going to react, then we're going to end up with the remaining mass. So now we subtract what's reacting from what we had available, and that will tell us how many moles of oxygen remain after this reaction. And then a quick conversion to mass. This was the example, and now you can pause this video, do the next 3 questions, and then just come back to see if you've got this right. Now in question 1, they tell you that you've got 100 grams of nitrogen and 20 grams of hydrogen available. They give you the equation, they give you the mass of the sodium, and they give you the mass of the hydrogen, and they ask for the limiting agent. Now remember, the first step is always to convert this to moles. So what I need to do is I need to convert this to moles, I need to convert that one to moles, and then I need to make a decision about who's the limiting agent. So first, converting to moles. You convert both the nitrogen and the hydrogen to moles. And now we have to decide which one is the limiting agent. So we're going to say, for all the nitrogen to react, how much oxygen do I actually require? So I'm starting with the ratio from nitrogen to hydrogen. It's always in the ratio 1:3 according to the equation. And then we've got 3,75, so you need cross multiplication there just to work out how many moles of hydrogen will you need if all that nitrogen were to react. And then the question you always have to ask yourself is, do I have enough? And then you just have to compare what we need with what we've got. We've only got 10, and for all the nitrogen to react, you would have needed 10,7. So obviously the hydrogen is the one that's going to be used up first. The hydrogen is the limiting agent. It's going to be used up completely. So now in future, I am always going to ignore the nitrogen and only work with the hydrogen because that is the limiting agent. In question B, they ask us for the volume of ammonia that can be produced. Now remember, hydrogen is our limiting agent. We're going to work with that to work out the volume of ammonia that is produced. So remember, we're going to work with hydrogen because hydrogen is our limiting agent. We're not going to work with nitrogen that is in excess. We're going to work with hydrogen that is our limiting agent. 3 moles of hydrogen will produce 2 moles of ammonia. And we have 10 that's going to react. So then we can work out the moles of ammonia that's going to produce. But that is not the question. The question was volume. So then we just need a quick conversion to volume. In number C, you had to calculate the mass of the reactant that was in excess. Now, in the first part of this question, we already worked out in A that 3,57 moles of nitrogen is available at the start of this reaction. Now we just need to know how many of that N2 is going to react with hydrogen. So we're going to work with the ratio, and we are going to say all the hydrogen, all 10 moles of hydrogen is going to react, and how much nitrogen will react with that. So we're working with that ratio to determine how many moles of nitrogen reacted, and then we're going to subtract that from what we put in. So we've put in 3.57, that was available at the start, and we're now subtracting the 3,33 that reacted to give us the number of moles, and then a quick conversion to mass. In number 2, they gave you a mass of calcium oxide, and they gave you a volume and a concentration of the HCl. And then they're going to ask you the same questions. Now, in the first one, to determine that limiting agent, we're going to convert the mass to moles, and we're going to work with the solution and convert that to moles as well. So we're converting the calcium oxide to moles, and we're converting that solution to moles. So now we know what is available. Next up, we need to decide which one is in excess. So we're going to take the calcium oxide and see if all the calcium oxide reacts, how much do I need of the hydrochloric solution? They're reacting in the ratio 1:2. That means if all 0.35 moles of calcium oxide is going to react, that will require 0.7 moles of HCl. And the question I always need to ask myself is, do I have enough? And then if I check, no, I've only got 0.4. So I don't have enough. That tells me HCl will be used up first. And that means HCl is my limiting agent. So in future, I'm definitely not going to work with the calcium oxide because that is in excess. I'm going to work with HCl, that is my limiting agent. In question B, they ask us to calculate the mass of the calcium chloride that can be produced. So I need to work with the hydrochloric acid because that's my limiting agent to work out the moles of calcium chloride and then convert that to mass. So first off, working with my limiting agent, and that's going to tell me 0.2 moles of the calcium chloride will be reduced, and then just converting to mass. In number C, they ask us to calculate the mass of the reactant that remains that is in excess. Now remember, in excess, that was the calcium oxide. So we work with the HCl that's going to react completely to determine how much calcium oxide is going to react with that. And that gives me 0.2. And then I'm just going to subtract what I put in and subtract from that what's going to react. And that gives me the number of moles. And that was what they asked us. Right, so that was question 2. I hope you all got that right. In question 3, they give you magnesium and they give you oxygen. They tell you 100 grams of magnesium and 336 cube decimeters of oxygen at standard temperature and pressure are available. So they give you mass and they give you volume. And the first question is determine the limiting agent. Now the first step is definitely converting to moles. So you convert the magnesium and you convert the oxygen, and then we have this decision step. So I'm going to ask, if all the magnesium reacts, how much do I need of the oxygen? So for magnesium to oxygen, they're in the ratio 2:1, according to my equation there, 2:1. So if all this magnesium reacts, which is 4,17, then it means I need 2,085 moles of oxygen. And then the question to ask yourself was always, do I have enough? And yes, I've got 15 and I only need 2. So that tells me oxygen is in excess and magnesium is going to be my limiting agent. In future, we are not going to work with the oxygen because that is in excess. We are going to work with the magnesium, that is our limiting agent. In B, they ask you to calculate the mass of the magnesium oxide that can be produced. So remember, oxygen is in excess. We're going to ignore that one. We're going to work from the magnesium, that is our limiting agent, to determine the number of moles of magnesium oxide. And then we just need a quick conversion for mass. Now in number C, they ask us to calculate how many mole of the reactant in excess will remain unreacted. In A, we've already worked out that we've got 15 moles of oxygen available, and we've already seen that 2,085 is going to react. So now we just need to subtract them. That gives you the number of moles that remain after the reaction. And remember, there was a lot of rounding, so they will mark somewhere between 12,9 and 12,94. Don't worry if you don't have the exact answer.